This is the real Tom Rose, and this is a really tricky problem. It turns out that it's fairly straightforward to solve it once I give you the trick for how to do it. But what's tricky about it is proving that you have the right answer. So let me show you what I'm talking about. So they give you a function, and it's a function that's based on x. And they tell you the domain of x, which is somewhere between 3 and 5, right? But what they want to know is what possible values of f of x can result from that. One way to evaluate this, and a nice heuristic for solving these, is let's just take the lower bound and the upper bound and plug those in. So let's do lower bound, which would be 3 times x of 3 plus 5. That equals 9 plus 5 is 14. And let's plug in the upper bound. So let's plug in the 5. So that would be 3 times 5 plus 5 is 15 plus 5 is 20. So you'd be tempted to just pick the third answer choice and be done. And that is the correct answer here. What's tricky, though, is making sure that you haven't missed something. So what this function looks like, 3x plus 5, if we plot it, for example, is it looks something like this. It's a line. So when I plug in the domain 3 and 5, we know that's going to generate some lower point and some upper point. Right? So this is the range. This is the 14 and 16, and 14 and 20 when we plug in 3 and 5. And because this is a straight line in here, you know, okay, I plugged in the 3 and the 5, so I know the absolute range of that. But what if this function weren't a line? Right? This isn't happening here, but for the future, in case this comes up, suppose that you had a function that didn't look like that line. What if it looked like this, and it went like that, for example. So you might plug in 3, and you'd say like, oh, for 3 I got this point, and when I plug in 5 I got that point. So 3 gives me 14, and 5 gives me 20, so the range is 14 to 20. But really the range is not 14 to 20 because this middle part of the function goes way down low. And you might need to say, oh, it actually goes down to like -2 or something like that. So in order to get these questions correct and have high confidence, you need to plug in those extremes like we did up here. But you also need to think about this function and ask yourself, is there something weird going on? Is there a part of that function where it really curves and goes somewhere strange? Because if there is, you need to figure that out, what that lowest point is. In this function, it doesn't happen. It was easy to plot. It was a line, so we're safe. But just be on your guard if that ever comes up.